We've been talking about how array lists are basically the next greatest thing since sliced bread. Unfortunately, array lists are, fortunately, while array lists are pretty nice, they do have their set of disadvantages. And one of those is the fact that it does this resizing process, right? So whenever let's imagine that we have an array list of, let's say, let's say 500 million elements. Okay? And then we try to insert one more. Let's say that the array list needs to resize at that point. It then needs to create an array list, or an underlying array, of some larger size, probably just doubling this, so it'd be 1,000,000,000. And then you would need to copy all 500 million elements over, and then just reassign the reference, okay? So that copying procedure and that enlarging procedure, that takes time, that can't be ignored. But for the most part, adding to an array list is fine. So adding is not really where the problem comes from. It's where one might start to see a problem, but it's not something that is always really pertinent. What is important is, let's say we have the same array list of 500 million elements. Let's say that we then try to remove the first thing in the list. Like let's say that we have some code that looks like this. While the array list dot size does not equal 0. So while the array list is not empty, we're going to do something like al.remove. And let's just say the array list is called al. Remove 0. So we're going to remove from the front of the array list. We're going to remove from the front of the array list. There's not really much beyond that. The problem here is, remember how this works. When we remove from the front of an array list, we're actually going to then copy all of the values down one element. Okay? Because you can't have any open spots in an array, or an array list. Okay? So think about the performance implications of this. This means that the time to complete this loop, if we create it as a function of time t of n, then t of n is going to be what? So the first time it's going to be 500,000, and then it's going to be 499,999,999 plus, then it's going to be 499,999,998 plus, you get the point, plus 3 plus 2 plus 1, and then the array list is empty. Okay? So, but again, think about the performance implications of this. This means that this will take, generally, an operation that if we collapse this into an arithmetic sum, we're going to get, so we're going to have what? I equals 1 up to n of just n. I. We're going to get what? If we collapse this, we're going to get n plus 1 over 2. So this is roughly 500 million squared, so I'm just dropping the constant here, over 2, and then we can pull out this 1/2, and then this is roughly an operation that will take 500 million squared operations, okay? And by operations, I mean like where an operation consists of shifting things down and things to that effect. So this is actually called a quadratic time operation. Okay? So the reason why it's called that is because the problem, the algorithm depends on the size of the input, which is n in this case. So really, if we want to generalize this, instead of using t of n, it would be t of n equals n plus n minus 1 plus n minus 2 plus plus 2 plus 1. So then that would collapse into this arithmetic series, and then we get the quadratic time operation. And that is really, really slow. So that's the big problem with array lists. If we're trying to remove from the front of an array list, then we're going to get really, really slow performance. Similarly, what if we're saying, while the array list does not have 500 million elements, we want to insert at index 0 the value of, let's say, I. So let's say that we have a counter out here, and then we're going to do I++. So that means we're going to insert 0, then we're going to insert 1, then we're going to insert 2, and it's going to be something like 500 million, 499 million, whatever, 3, 2, 1. Okay? So the problem is that when we're inserting, we have to shift everything to the right. And if we do that, we're going to run into the same problem. Okay? And on average, if we insert somewhere in the middle of the array list, we're going to have to shift roughly half of the elements over. Okay? And same if we remove. If we remove on average somewhere that's in the middle of the array list, we're going to have to remove, or we're going to have to shift down half of the elements. Okay? So let's just see what that looks like in code. So let's very quickly create an array list. I'll just call it AL for the sake of correspondence. Let's first insert 500 million elements into the list. Okay, so we'll do al.add_i. So now, as you might expect, the array list contains 1, 2, 3, ... 500 million. Okay, now let's print out a comment that says finished adding, and now we want to do what we just said. So while al.size does not equal 0. So another way to think of this is, and IntelliJ even tells you, replace this with is empty while it's not empty. Okay, so while it's not empty, we're going to do al.remove 0. Okay, so now let's just copy this, and then we're going to say finished removing. So yeah, so let's run this and let's see how long it takes. So it shouldn't take too long to add everything. Hopefully. I was expecting this to run much faster. I'm a little surprised that it's not. Okay. Let's do 500,000. Okay. So we finished adding very quickly, but now this remove operation, this is going to take a good while. Okay. And we're not going to... Oh, it actually didn't take that long. Okay. So, but it took considerably longer than adding the elements. So let's go up to 5 million and let's see how long that takes. Okay. So 5 million was very quick as well. So if we're removing things from the front of an array list, it's going to take a quadratic amount of time in proportion to other operations, right? So that's not very good, okay? And again, we're not going to wait for this to finish, but you know, just removing that many elements from the list shouldn't be this slow. And indeed, if we picked a different data structure, perhaps it would be much faster to remove from the front of an array list. Now, what do you think a solution to this is? What if we want to just clear out an array list? Well, one thing we can do is do al.clear. And yes, this is still running. I haven't closed it yet. Okay. Another thing we can do is actually, instead of removing from the start of the list, we can remove from the end of the list. Okay. So let's remove the element at the let's say the index -1, and that will always remove the last element of the list. Okay, where we don't need to shift anything down. Okay, again, still running, but let's just terminate it and let's see how long this takes. So there we go. So I mean, yeah, so we finished adding instantly, then we removed them all almost instantaneously. So this is the power of actually making good design choices, but Again, what if the problem calls for us to remove from the front of an array list? Well, then it's important to consider whether an array list is a good design choice for that problem. Okay, so there are other data structures, there's another list type, and there are other data structures in general, which are part of what's called the Java collections framework that we'll talk about, that are better suited for this case. Okay, so in the next section, we're going to go through a whole bunch of different Java collections that are extremely important and are fundamental to many algorithms that we're going to talk about, not only in this class, but in almost all of your upper level computer science classes. Okay, so we're getting to the good stuff next time.